But what is a bug? A bug is whenever software does something that we don't want it to do. Or, I guess the flip side on that one is whenever software doesn't do something that we do want it to do, right? Either one of those cases would be a problem, okay? And it's a problem that needs to be fixed by the software developer who's in charge of it. So let's take a look and see what we got going on. So bugs, well, okay, so we know, hey, it's your code. Ultimately, this is the product that you are producing, okay? That means that making sure that the code does what it's supposed to do, and flip side to that, it does not do things that it's not supposed to do is your responsibility, and of course, if it's your responsibility, it comes down to being your reputation. So are you valuable to the company that you work for? I don't know. It really comes down to whether or not you can produce valuable things for the company. Software development bugs are a fact of life. I'm sorry about this. The code that you write will have bugs in it. There's nothing you can do about that, okay? The code that you inherit will have bugs in it. And you need a process to both fix them, and if you could get away with it, you'd like to avoid them in the first place. Anything you can do to minimize the number of bugs that are in your life will make your life a much better place for you. Alright, so more often than not, what's going to happen is that you will actually probably produce reasonably good code, right? We've talked about how to do that. You take a look at a user story, break it up into tasks, figure out which iteration you're going to do it in, you sit down to do it, you actually create unit test cases for it, you check it into a code repository, you've got the continuous integration stuff going on, etc. You got all this stuff going on. Basically, you should be able to stay on top of your code and make sure it's got no bugs in it. Where you get sort of screwed over is what happens when you inherit code. When somebody gives you some code that does something that you need as part of the project that you're working on, or when you get a new assignment in your career, you got dropped in a different part of the company, and all of a sudden you're now in charge of 10,000 lines of code that you never seen before, and you never wrote, and you have no responsibility for prior to beginning this new job. Bam! All of a sudden, your life just got a lot more complicated. Now, when this happens, you got brand new code that you're responsible for. What you really need to do is say, listen, this is crazy, it's out of control, I've got no idea what's going on, but I do have a system. We've talked about what that system is. I have a system for staying on top of code to making sure that it's under control. So you're going to drop this new code into your existing system. You're going to update your bug tracking system to handle issues that come out of the new code, because there will be issues. Okay? You're going to organize the code that you got. Look, you didn't just get code. Okay? You got source code, you got hopefully test cases. Dear God in heaven, you hope you got test cases. And perhaps any sorts of documents that came along with it. User cases, etc., 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 user stories, pardon me. And you take all these and you place them in their own separate directories. The one thing you don't want to do with code that you inherit is you don't want to mix it up with your existing code. You want to put this all off in a separate place. Remember, we talked about this last time. If you've got a lovely clean glass of water, and you've got a glass of muddy water, and you pour the muddy water into the clean water, congratulations, now everything's muddy. You know the code that you filled out is nice and clean and works well. Code that you inherit, you've got no clue about. So you really don't want to mix the two up. You want to keep them separate until you can get the inherited code cleaned up. You're going to want to create a build script that can handle the new code. Remember, we talked about build scripts. That's where we automate the process of taking all that source code and turning it into an actual working program. You know, the new code that you got has its own sets of dependencies and libraries that it brings in and all this sort of stuff. Who knows what the heck's going on there. Create a build script, make sure that you've automated that so that it gets built correctly every single time. You want to place the new source code into your configuration management tool. Hopefully that sort of goes without saying. You have no idea how this code got built or who built it or who made changes to it. But what you want to make sure that you do know is going forward, who's making changes to this code, right? Put it into a configuration management system, and what that means is if anybody wants to make a change to it, they have to check the code out, make changes to it, and then check the code back into the system. And all of a sudden you'll have basically a paper trail. You'll have a list that indicates who did what and when. And if you don't like the changes they made, you can always, of course, back out those changes because your configuration management system is going to be keeping different versions of that code every single time you make a change. Okay, you want to turn on the continuous integration so the new code gets tested as it gets updated. Just a quick memory recall here. Continuous integration says, listen, if I check code out of the configuration management system, make changes to it, when I check it back in, that's going to kick off automatic testing of that code. I'm going to automatically run test cases against that new code just to make sure that the person who made all those changes to it didn't screw something up, or didn't break something. Gotcha. We're going to create more tests with the new software. You know, the question is how much of that software is currently being tested? We've talked about test cases, and we've talked about coverage, right? I'll bet you $1 that software does not have 100% coverage when it's test cases. So you're going to have to take a look at the test cases you have, figure out what portions of that software is currently being tested, and then you're probably going to have to add test cases to cover more of it. Remember, our rule of thumb, and it's just a rule of thumb, is that we'd like to have about 85, maybe 95% of that code covered by test cases that we have. Okay? And finally, the last thing that we want to do is we want to create bug reports for issues that are found, which works well with our bug tracking system, right? So as we use the new software more, as other people use the new software more, they're going to find issues because they always find issues, right? And what we're going to want to do then is we're going to want to make sure that any issues that they find get logged and reported so that we know about them. We can make the software better, but we can only make it better if we have a list of what's wrong with the software. So there's a lot of stuff to be done if you inherit code. But basically what it is you wrapping your arms around that code and saying, listen code, I'm in charge here. I have no idea where you came from. I have no idea what your history is. I have no idea who wrote you. But now that you're mine, I'm going to make sure that you fit within the process that I have for managing and correcting code. There's a lot of things that you could do when you get brand new code, and as eager, excited engineers, you go, wow, I've got new code, I'm going to jump right on it, which is good in one way. But there's also a bunch of things you probably don't want to waste your time doing, okay? And they're really attractive. One of them is document the code. Hey, here's a bunch of code, sure, see you later. Whoa, I got new documentation. Maybe I should hunker down and create some documentation for this code. And the answer is, well, it's always good to have documentation for code. There's no question about that. But the problem is, wait, you've got a primary issue. You've got to make sure this code works before you worry about documenting it, okay? So spend your time making sure that you've got good code. Don't waste a lot of time documenting it, okay? Treat it like a black box. Treat it like you don't literally have any documentation for it. There will be time in the future for you to come back and put documentation on it. Next thing is you might want to, like, I don't know, get counts of number of lines that you have, an estimate, come up with an estimate for how long it's going to take. You know, I love numbers, you love numbers. We like putting numbers together and say, oh, the inherited code, 10,000 lines of code. It's got like, 15 statements per line. It's going to take, stop. That's all made up. Okay? You can count your lines and come up with fake metrics, but it's not going to be worthwhile because you really don't know what this code does. So any of those metrics that you come up that tell you, hey, this is how long it's going to take me to fix it or get on top of it, they're basically bogus. You're making them up. They don't really mean anything, so don't waste your time doing it. And the final thing that we recommend that you don't do is what we like to call as a security audit. Is this code secure? Does it do things securely? Do I have any gaps or leaks or any place where bad guys can sneak in around the edges? The answer is, maybe there is. Who knows? But here's the thing, you're probably going to end up making big changes to this code. So doing a security audit right now doesn't really make a lot of sense because really the code's going to change, and it's the changed code that you want to do the security audit on. So if you did a security audit now, you're just going to end up doing another security audit later on. So the thought is to stop. It's always good to be secure, so don't take the wrong story there. But look, live with the code as it is right now. Focus on getting on top of the code and understanding what it does, and more importantly, how it does it. Make any changes that you have to, and a little bit further down the road, that would be the time for you to actually go ahead and make the security audit. What to do when bugs are discovered, because bugs will be discovered. Okay? The most important thing that you need to understand is every time you find that something's wrong with your code, it's going to have an impact on your next iteration schedule. So let's think about it. Remember, we've got an iteration schedule, and it's how long? 20 working days, but calendar days, it's about 30-ish days, okay? And remember, in a great and fabulous world, what we're going to do in an iteration is we're going to spend our entire time implementing brand new, shiny features for our customer, okay? But the reality is it ain't going to happen, and the reason it ain't going to happen is because we live in a world filled with bugs, right? So what you have is a trade-off to make. The question is how many bugs do you have? How many bugs have to be fixed in the next iteration, and how much of the remaining time can you spend working on new features? So every single iteration will be a combination of bug fixes and new features, right? And it's up to you to figure out what that balance is. If you've got really lousy code, you got bugs coming out of your ears, there's a good chance you're going to have an iteration that's almost all bug fixes, which is potentially good news for the customer, right? A whole bunch of things that aren't working are going to get fixed. But for that iteration, they're not going to get any new functionality, which potentially could push out the whole project by a month or something like that. You just have to be aware of that one. Ultimately, you want to talk with your team, okay? And every bug has a different characteristic. If there's a big bug, okay, that has to be fixed because something is horribly, terribly wrong, it is potentially going to have a big impact on your schedule. And if you discover a big bug that does need to be fixed, and it needs to be fixed right now, you're going to have to go back and have a little chat with your customer and say, hey, guess what? We found this thing, this really, really bad thing that's going to cause all sorts of problems. So we're going to spend time fixing it. It's going to change your schedule. Let's talk about what the new schedule is. Let's come to an agreement that we're going to be spending our time in the right way. And the final thing is, if you're going to go talk to a customer about the impact of bugs on release schedules, it means you're going to have an estimate for the bugs that you're going to be fixing. How long is it going to take you to fix a bug? This is a tricky question to answer. Look, I can tell you what's wrong with your software. It's not doing this, or in this situation, it is doing this. So that's easy. I can tell you what the problem is. Telling you how long it's going to take you to fix that problem, that's a little bit trickier, right? You're going to have to go into the code. You're going to have to figure out what's happening in the code. You're going to have to figure out how you're going to fix it, and then you actually have to go ahead and make the change.
Test the change.
Then you got to test the change, right? That was sort of a trick question there. You're exactly correct. So look, that takes time, right? So coming up with an estimate for how long it takes to fix bugs is a tricky thing to do. All right. First things first. So you can get it so you can build working code. If you've inherited code, the very first thing you want to do is get control over the inherited code, put it in your version control system, write some build scripts, and add on and turn on your continuous integration. When you do that, you're on top of the code. You own the code now. There's nothing going to be changing in that code that you don't already know about, which is good news. Now, arguably, this isn't going to help you that much. Okay? It's not going to reveal any new bugs. You've just got your code under control. Okay? But you're now ready to find and tackle the bugs, right? Because nothing's going to change in your code unless you let it change, which is the key thing. Fixing code that you didn't write. So first off, everything has to be based on customer-orientated functionality. Everything in your code had better be related to something that the customer wanted. You fix the code to satisfy user stories. If the code does something that it's not supposed to do, the reason is because it's doing something that's at odds with the user story. Okay? You only fix what's broken and where you have test cases that fail. You can spend a lot of time fixing the way a screen looks, changing how you transition from screens and stuff like that. But if it doesn't matter, don't waste your time doing it. You're looking for test cases that have failures, okay? And it's got to be something that's actually broken in the code. Ultimately, your test cases are your safety net. And they're safety net in two ways. First off, if there's something wrong with the code, hopefully you have a test case that's failing. Say, whoa, something's out of sort here. Cool, not a problem whatsoever. So you'll go in, you'll make a change to your code, you'll fix what's wrong. Good news, that's fantastic, and stuff like that. But here's the thing, there's a good chance that when you make a change to that code, you're going to break something else. Sorry. It's the way of the world. But the cool thing is that your test cases should cover you on that one. If you break something else, all of a sudden you should have a different test case that starts to throw a red flag, and you're like, darn it. Okay? If you don't have any test for code, you have to assume that that code is broken. Then what's your alternative? If you don't have a test case for the code, what are you going to tell? What are you going to tell me? Oh yeah, no, that code works. 50-50 chance, right? Maybe yes, maybe no. If you assume it's broken, then what's going to happen is you'll create a test case for it and you'll confirm that it actually works. And remember, functional code triumphs beautiful code every time. I truly do enjoy writing beautiful code, but look, customer doesn't care. Customer's never going to see your code, right? Get the code to run, get the code to do the right thing, and you're golden, right? Customer doesn't really care about it. So if you inherit code that looks really, really ugly, live with it. As long as it works, live with it. Don't spend a lot of time cleaning it up or making it look pretty. First steps when you get code?
What about thing that comments?
Go touch it. Okay, go with it. Remember, treat the code like a black box. Okay? And the reason is because you've got limited time, right?
Okay.
So where are you going to spend your time? Look, you know, I hate owning ugly code, right? It sort of rankles me, right? It's like, that code is not good. But if it works, I mean, arguably, I may never have to touch it. I may never have to go there and do anything like this. I mean, I could spend hours cleaning up and fixing up the stuff that has to break it. And I could possibly break it, I could do a lot of interesting things to it. But if it's not necessary, my time is better spent doing new functionality or enhancing stuff that's already there and stuff like that. You'll always get a chance eventually to come back and fix it up. But don't do it right off the bat. It's just not worth it. When you inherit code, initially you're going to want to find out what functionality in your inherited code works, right? So they told you it does certain things. Maybe it has some documentation that says this code does this. Oh, well, that's good, but I wonder if it really does do this. Okay? The way you find out is by creating unit tests that test all the functionality that your user stories will need. Arguably, you would hope that when you inherit code, you'd get a whole bunch of test cases that would come along with it. It doesn't always happen that way. Sometimes you just get the code. If that's true, then you've got a job ahead of you where you actually create the test cases to test that code. So now, we would expect that you probably will end up with some test cases that are failing for the new code. Okay? You're not going to know what it's going to take to fix the test cases, and you won't know if the reason that the test cases are failing isn't because the code's not working, but rather because the code simply isn't there. The new code doesn't do that function that you're trying to test. Okay? So that's going to require some checking on your part. One way you can do some checking is what's called spike testing. Okay? I've inherited some new code. I've created some test cases for it. Maybe I've got some feedback from users. I know this code has errors. I've got a list of errors. I've got 20, 25, 30 errors in this code. How long is it going to take you to fix those 20 or 25 or 30 errors? It's new code. I got no freaking clue how long it's going to take. That's where spike testing comes in. Okay? What you do in spike testing is you do a burst of activity. You fix some errors. And you take a look at how long it takes you to fix those errors. And you're going to use those numbers to figure out how long it's going to take you to fix all of them. So here's a spike testing plan. Take 1 week to conduct your spike test. Pick a random sample to fix from the tests that are failing. At the end of the week, calculate your bug fix rate. Real simple stuff here. In this week, how many bugs were you able to fix? Divide it by 5 days in a week, and you have your daily bug fix rate. Okay? Really big science here, but this is pretty straightforward stuff. So what's spike testing going to reveal? Okay, test cases reveal how much your code was failing. Your spike test should reveal how long it's going to take you to fix your bug. So if we fixed 4 bugs in 5 days, that comes out to be what? 0.8. That seem right? Yeah. Okay, great. So how long will it take to fix all of our bugs? Well, let's take a look. We're going to take 0.8, which is how fast we fix bugs. Now we had 13 bugs. We fixed 4 bugs when we're doing our little spike test, which means that we have 9 bugs left. So it's going to take us 7 days, we calculate, to fix the remaining bugs in our code. All right, 7 days is still a made-up number. This is still sort of a guesstimate, right? But, for what it's worth, it's probably better than just pulling a number out of the air, right? I've got a little bit of science behind this, okay? Now, the other thing that you can do is well, you'll never know exactly how long it's going to take you to fix the bugs. But we really can't be sure how long it's going to take. Spike test is just going to allow you to make a more accurate estimate, okay? It does give you quantitative data on which to base your estimate, okay? You should be more confident when you go to your customer and you say, hey, it's going to take me 7 days to get the rest of those errors wrapped up, okay? You don't actually know how bad things are going to be. Some of those bugs may turn out to be pretty horrific errors, okay? And they can blow up on you. Deal with it, okay? There is something else you can do. You can go to your team, right? And what you're going to discover is your team has a gut feel about the remaining bugs. Depending on the effort, the level of effort that they had to go through to fix those 4 bugs that they fixed in the week. A little bit of effort, a lot of effort, or a super duper awful lot of effort. They've got a gut feel. And you can work that into what's going on. So you got your 0.8 times your 13 minus 4. But if you divide it by 0.7, which says your team is not all that confident, they're like 70% confident that this is an accurate number. Remember, it was going to be 7 days. Let's pop that 7 days up to 10 days. And when you factor in your team's gut feel into your estimate for how long it's going to take you to actually fix bugs, all of a sudden you've got a number that you can have even more confidence in. When you go talk with the customer and say, hey, you know, we've got 9 errors left, we think it's going to take us about 10 days to get it taken care of, that's probably a pretty good estimate. I don't think you can arguably do any better than that estimate in terms of confidence in what you're telling your customer. It's always all about time, okay? When you know how many bugs you have, and you have a good guesstimate for how long it's going to take you to fix those bugs, the next thing you have to do is you have to go back and take a look at your planning for your next iteration. Remember, you've got this fantastic, 20 days or so worth of development time to work on the next iteration. How much of that time are you going to carve off? Not to implement new functionality, but rather to fix the functionality stuff that you already have. There's a good chance that there's fantastic, shiny new functionality that you are hoping to be able to implement in the next iteration. But depending on how many development days that new functionality is going to require, and depending on how many bugs need to be fixed now, the two may not be compatible. And if you've got a bunch of bugs, that shiny functionality may slide from this iteration to a future iteration, just because you don't have time to do it. The truth is, of course, when you finally do end up delivering your code to your customer, there could still be bugs in it. This happens every single time, right? The question is the severity of those bugs. Are they big bugs or little bugs? Is it really going to impact your customer? Is it not going to be that big of a deal? Here's the thing, you delivered code that works. It's the most important point, especially if you'd like to get paid for what you're doing. You want to be inherited code that's not currently being tested by any test case. There just wasn't time to develop test cases to cover all that code that got dropped on your lap. However, you're comfortable that your user stories are covered by test cases. Cool. All right. So all the new functionality you put in do have test cases associated with them. And ultimately, when it comes down to it, real software success is all about delivering functionality. Customers said, I want this, you gave it to them, they're happy. Okay? They'll use it, they'll probably have issues that pop up. That's what bug reports are for. You'll go back, you'll make changes to it, you'll work it into the next iteration. Right? So we make progress every single time. So what did we cover today? We talked about how you can actually deal with inherited code, which in your software development careers will happen more often than you might imagine. What do you do about bugs in your code? Okay? We talked about spike testing, which allows you to figure out pretty much how long it's going to take you to fix bugs in a section of code. And we talked about estimating bug removal efforts. Wow, all that in just a short period of time. Well, that sounds pretty cool. Whatever shall we talk about next time? Software development in the real world. And no, it's not an MTV show where they lock people in their house. And no, we don't do that at all. We're talking about the real world where we actually go out and do software development. Fantastic! All right. Well, you know, I've got some information on Python, and I've got some information on sets. I thought we could maybe spend a little bit of time talking about that. Why don't we plan on getting back together in 15 minutes? So we'll be back here talking about sets at 9 o'clock.